Hi, my name is Kevin Harbin. I'm demonstrating the Electrohydrodynamic thruster for design of electromechanical systems. First, a quick preview of where we're going. Now, for a quick how-to. I used the thinnest balsa wood rods I could find, 2 mm square. Cut lengths 12 inches for the sides and 4 inches for the corners. Standard aluminum foil, 37 inches by 2 inches. 30 gauge wire, and some superglue. Glue the sides 2.5 inches from one side of each corner to produce a triangle like this. I slightly rolled the top edge of my foil just to ensure there were no sharp edges. Glue the foil to the sides, leaving a 1/2 inch foot at each corner. Strip the insulation off your wire. You'll need about 48 inches. Wrap it around the top of the model, approximately 1 inch from the foil. Keep it as consistent as you can. Wrap it tight, but not taut. You don't want to break it. Leave the extra foot pigtail. You'll need it in a minute. The effect requires a large applied DC voltage. If you happen to have a kilovolt DC power supply on hand, use that. Otherwise, a simple one can be scavenged from an old color CRT. Remove the casing. A CRT works by creating a huge potential difference between the electron gun and the screen. You can use this connection to get your high side. Connect this to your upper wire. Ground can be found just about anywhere. Connect it to the foil with the bared end of your 30 gauge wire. Here it is all set up. You can see I've tethered the corners to the surface with a string. You don't need 10 kV smacking into just anything. Now, in action. The model is constructed and a high voltage differential is applied. The wire, having a small cross-section, creates a corona of positively charged air molecules, or ions. These ions are attracted to the ground conductor by Coulomb's law. Similarly, the collector is attracted to the corona. As the ions travel down towards the collector, they are restrained by air molecules not carrying charge. This mass of neutral air holds the ions away from the collector, and the collector is allowed to continue traveling towards the corona. As the ions collide with the neutral mass, the neutral molecules are knocked away but not attracted to the collector. This can be felt as a gentle breeze below the lifter. The ions continue to travel through the neutral mass to the collector to complete the circuit. The resulting net force on the model is in the upward direction. The wire is continuously charged, so the corona is replenished, continuing the cycle. As seen in the dark video, the sharp corners develop a corona discharge. These sharp corners have a higher intensity of charge, and this creates plasma, which is conductive. This is important to note because since Coulomb's law is inversely proportional to the square of the distance, to create the largest force, you would want the wire and collector to be as close as possible, without allowing this conductive path to create an arc. An arc, at minimum, will shunt all the power, removing the desired force. At worst, it could set fire to the balsa or damage the power supply. Improvements to the design would be to decrease the angle of these corners, even to the point of using circles and toroids. I'll conclude with a clip showing the air movement.